we were discussing the first example in the last class that in the Lisp, this is the simplest equation. That means there is no nested bracket. Okay, only one boundary bracket. So in this case, what we do, we use the first one. We write this one after another, A, B, C, D. Each of them have a boxes like this. Okay, each box has two part. First, we can call it list. Each part of the list has two part. Okay, first part points to the element, that is A. Second part points to the next element. So for the A, the next element is B, so it is pointing to B. For the B, the next element is C, so it is pointing to C. So it's almost like a linked list. Okay, now if you don't have any nested bracket, it is very simple. You just draw the list, and end of the list, when like D is the last element of the list, so you just, instead of pointing to another node or another list, you just point it itself. Okay, that's it. So we start with this one, we end with this one. Now the problem starts with when we have a nested bracket. Okay, so I will go with the nested bracket one. So let me clear it up. So let's say that this one, okay, if you look closely, this one is a bit complicated. Let me start with another simple example. Let's say um, A, B, C, D, and in this example I will just add a nested bracket here. Okay, so normally when we have multiple brackets, we use first bracket, second bracket, but in this one we only use first bracket. Okay, so let's say that instead of doing this first one, we will do this one. Okay, A, B, C, D. So what should be the approach? So first of all, we'll break it down into different levels. So one way to do it, okay, there are many ways to you can do it. One is that you can write A. So whenever you face a bracket, okay, you will make it like this, that they go. Okay, and then you will resume. So this is one way to do it. So whenever you see there's a bracket, you just push them one level down. Okay, that means they will go one level down. So you can, one way to do this, I'm going to the drawing part later. First I'm discussing the equation. Okay, how to best formulate the equation. So whenever you see that there is a bracket like this, you just push them one level down. And then how to draw it? So the drawing approach remains same. Okay, what you do, you have to draw boxes. Okay, but instead of drawing one boxes at a time, what you will do for this one, okay, let's see, oops, just a minute. So let me clear this up, take a clear screen. Mm, here, I think this will be much better. So the equation we're trying is A. Then we go one level. So this is our main equation. So what we do, first we normalize the equation. You don't have to do it in the exam. I'm just showing for you. I'm just showing it so that you can understand how it's done. So then I write B, C here, and here I also go with the D. Okay, now after this is done, okay, now my part, I have to draw the boxes. So I'll start with this one. So I have to draw it for A, then I have to draw for B, and then D. Okay, so for B and C, I will just draw one boxes, and then what I will do, okay, I will start with the division part. So again, each one will have a point here. The okay, this is difficult to see. Now, the first one will usually point to A. The second one, instead of pointing to a specific element, it will point to B and C together. Okay, so this one will point to both B and C. So we will draw another label as you have a bracket here, and the last one will point to D. So for A and D, it's almost same. Okay, and we start with the arrow here. But for B and C, whenever we saw that there's a bracket, okay, we actually pull them one level down, and then, okay, just a minute. So I think I have to take it a little bit up. Yeah. So we just draw them one level down, okay, and then we draw again here. So we will draw the list for B and C in this place. So here we will go B and C. So at first it feels like a little bit confusing, like why B and C is in here. So to remember what we do, okay, we try to remember in this way, that every time you face a bracket, that means they will actually, they are nested. And whenever we means they are nested, they actually go one level down. That means A, D, and in between A and D, this is the nested part. So let us go back to the slide and show you an example. So if you look here, okay, in this case, we have A, B, C, D. So first one in this example, okay, they have done, I think, which one they have done here? I think they have done this one, okay, even though they're, this is the, this one. Let me check one more time. E, F, G, yes. So you see first A, this is not nested. So A is as usual, okay. Then B, C, they are nested. So they will go one level down. So here is B, C. Then D is not nested. So D will stay here, okay. Then you see E, F, G, okay, all three are nested, so they will go one level down. So after that, E, then FG is again nested, so FG will go one level down. So to remember easily, every time you see a nested bracket, okay, the list will go one level down. To practice it, let me start with another equation. Let's start with this one, okay. So you see P, Q, they are not nested. So you will just normally draw P and Q just like this. Then RS, they are nested. So you will go one level down. So RS will come one level down. Then T is not nested. It will here as it is. Then UVW, all three are nested. So they will go one level down. Okay. So whenever you start drawing UVW, okay, you see that, okay, W and UV is also nested. So they will go one level down. So let us draw it. So first I'm drawing this one, okay. So again, let's start with the equation. You don't have to draw the equation during the exam. It's just for you to practice at first. Whenever you get the idea, it's a bit difficult to get the overall impression of what's happening. But once you get it, this is one of the most simplest thing that we'll see in the course. And then we have an X, right? Okay, so X. There will be another bracket. I think it's missing here. Okay, so again, so first let's remove the brackets. So P, Q, I'm removing the first bracket, P, Q, R, S, T, U. So I'm not removing this bracket. I'm only removing the bracket here and this one. Okay. V, W, X. Okay. Now P and Q will be here, but R and S are nested. So they will go one level down. Okay. Let me write it this way. R and S. Then let's say T will be here. Then U, V, W, they are they will go one level down. So we can say here, let's say that U, V, W, and finally X will be here. So this is the first operation. So now we'll start removing the brackets again from here. So PQ will be as there, PQ, then the T will be here as well. The X will be here. Okay. And because of R and S, they have brackets. We'll remove the brackets. So they will be simple R and S. Okay. And for UV, I will remove the brackets. So it will be U, then VW. So I only remove the outer brackets, this one and this one, and this will be like this. Okay. So as they have a bracket here, again we will go one level down. Okay. So P, Q, then we have T, we have X, then let's say that we have R, S, no bracket, so they will stay here. U, there is no bracket, so it will stay here. But for V and W, as we have bracket, we have to pull them one level down. So let's say we'll write like this, V and W. So this will be our whole structure. Okay. Now if you start drawing, that means P and Q will be here, then we'll go one level down, then we'll draw this, then we'll draw that. Okay. So I will try to draw it here as well, but as soon as I move the cursor, I think it totally breaks down. Let's see. Yeah, it totally breaks down. So you get the idea how it happens. Anyway, so just to give you an example, try this today. Okay, and if you still have any problems, okay, I will discuss it again in the next class. But I think after you go with this two example, the first one, the second one, and the third one, you will get the idea. Okay, and one more correction, that in this one he is pointing to this equation. Okay, but it's actually done for the first equation. Okay, because you see there's no I here, so this is actually pointing to this one. Don't get confused. Okay, okay, let's go for the next part. So normally whenever we are learning Lisp programming language, these are two dialects of Lisp. We have talked about this in the last class. First is the scheme, and there's the common Lisp. Now scheme was developed in MIT again in mid of 1970s. So like you can guess 1965. It was a small programming language and used only for static scoping, and the functions that we had in this, okay, were first class entities. And one of the problem with the first class entities is that you are actually not familiar with this type of functional approach. So I will show you an example how it works. And lastly, in the scheme, the syntax that we use are very small and very simple, and it was actually very good for application or in the case of educational institute, just like C programming. Okay, if you want to learn programming, C is very easy to remember because the syntax are very small and easy to remember. And then we have the common Lisp. What they did whenever they are developing common Lisp, they actually tried to combine the different features of several dialect of Lisp into one simple programming language. So as a result, it actually became complex because you are trying to combine multiple version into one single version. Okay, and that's what actually makes it not only complex but also a large programming language, and very happy to operate. So after they tried with this, okay, so they actually at the same time they are trying to develop a universal language. Okay, so just like in English that everyone speaks, everyone understands, okay, they try to develop a universal programming language that will run on all the machines, that will be used by all the developers. Okay, not only for scientific use, for business use and everything. So to do that, okay, the environment of development was that Fortran had barely arrived. So it was, we're talking about 1960s. Okay, so we just have one or two version of Fortran. Many other languages were being developed for specific machines. So like if you have a computer, you would develop a one programming language for your own computer. Okay, if you had another machine, you would develop another programming language. So it was totally chaotic situation. Everyone was going with their own way, and none of the languages were portable because all of our machine dependent specific. And more importantly, there is no common communication method for algorithms. So whenever you want to even if you developed an algorithm, the other machines will not understand the algorithm, or other scientists even will not understand the algorithm because the way you have written it. Okay, now we have many approach, like we use a pseudocode, and then we use also very simple flowcharts to explain the algorithms. In your inter ICT book, I think you had you got familiar with flowcharts, how the flowcharts work. And then so overall all this environment and all this confusion actually led the scientists to develop an universal language that they named International Algorithmic Language. So this was a programming language they tried to develop for especially algorithms, and the first version was ALGOL 58. And if you go to the timeline, uh, here, if you look at the timeline, ALGOL 58, okay, is almost developed at the same time as Fortran 1. It actually came from Fortran. Okay, so they took the idea because Fortran was very popular in that time. Also it was, they had very interesting features. Okay, so they took the different operations and ideas from Fortran 1 that was developed in 1957, and around 1958 they developed ALGOL 58. Now, the concept was that in ALGOL 58, the overall concept was very formalized. They knew exactly what approaches they were trying to take. Okay, so they have given you some flexibility. For example, in Fortran, there was the variable names were fixed. Okay, I, J, K, L, so on. But in this ALGOL 58, you could names could be of any length. Okay, array could have any number of subscripts. Parameters are separated by mode. So like you have input parameters, you have the output parameters, then the subscripts are used in brackets. So the same way we do here now, like for example, if we want to access an array elements, okay, what we write a I. So we know that we are going to access the ith index of a array. So this is you see the I is in the brackets. So this is the same concept. The subscripts were placed in brackets. Then we had compound statements such as begin, end, and we use semicolon as a statement separator. And even today we use this same idea in C program as well. We use semicolon as a statement separator. They introduced assignment operator for all the cases. We had if and else if clause, and it was not meant to be implemented. That is the interesting part, because they were trying to develop a programming language so that all the scientists actually could communicate the algorithms or exchange the algorithms in a way. Okay, so it was more like the approach to take a pseudocode, not actually the actual program. Okay, and after 1959, okay, IBM actually dropped its support that okay, ALGOL is not working. But that's what happens in and after that, uh, all the scientists, okay, they actually sat in a meeting, in a 6-day meeting in Paris, okay, and they actually modified this ALGOL 58, okay, and they after much discussion, okay, they actually created some new features such as block structures that we use today even in the function, okay, that you use a local scope. They use 2 parameter passing methods, subprogram recursion, stack dynamic arrays, and but it did not have any string handling. We're talking about 1960, okay. So after all these features, we even saw them reflected in today's programming languages, even after how many years? 50 years, let's say. No, not 50, 60 years exactly, now 21. So all these features they have, all the ideas they came up with, that how to write the block structures, the loops, and the subprogram, the recursion, we also still use them in some of the programming languages. So they modified it in 1960, and then okay, ALGOL actually become a bit popular. Okay, so to evaluate ALGOL programming language, the success was it was the standard way to publish algorithm for over 20 years. So from 1958, even after the IBM dropped its support and they thought that this will not be that much popular, but after the scientists sat together and modified the language, okay, it actually was popular to publish algorithms for 20 years. So it actually served this purpose. The main purpose was so that scientists could communicate among themselves. Then all subsequent imperative languages are based on it. So whether it's C programming language, C++, if you look here, so this is the ALGOL. And if you trace back from ALGOL, we have here, we have this modular language, which leads to Python. Okay, from ALGOL, we have Simula 67, okay, which leads to C programming language. From ALGOL, we have a Pascal, which leads to Haskell. Okay, so this one programming language or structure of this programming language is not only like PLI, it leads to PHP, JavaScript. Okay, it also leads to Python. So all the programming language, the concepts that they developed there is actually popular in today's languages. Okay, wait. So this is one of the big success, and it is the first machine independent programming language. Previously, all the programming languages are dependent on the machine, and they use syntax formulas such as BNF, which we will learn in the next chapter. Okay. So this is the first machine independent language, which was a big success because now they actually could communicate among themselves. And it was the first language whose syntax was formally defined at BNF. Okay, so BNF, eBNF, we'll go over this in the next chapter. The failure was it was never actually widely used, especially in US, because they had some at the same time. Okay, even though it was common and it was a standard way, but it was not that much popular. Okay, just like the Fortran was. And again, it lacked the IO and the character set that makes program non-portable. It is too flexible. Okay, so that means everyone can do what they want in their one way. So the compilers, running the compiler is very complicated. And then the main issue was that IBM was not providing any support. If you remember, after 1958, IBM thought this will not work. Okay, so they did not actually provide any support or any updates or bug fix in case of ALGOL 60. This is an example of an ALGOL program. So if you look closely, the first it starts with the program begin, then it declares an integer array, and they use a subscript from 1 to 99, then sum equals to 0. So and then this use a for loop, okay, and it uses until. And so most of the syntax, even though are unfamiliar because you did not have use listen, until in any programming languages, but you get the idea. Okay, it's still it sounds seems familiar to the current programming languages that we use. So next came another programming language is COBOL. Okay, now to understand why we're studying the COBOL, okay, you have to see that why they developed the COBOL. Okay, so the COBOL, they are trying to actually develop a programming language that will be able to help, or that will work perform well in the business uh, section of the industry. Okay, so they could actually develop a programming language that should be very simple, not number zeros and ones, or assembly, just like assembly instructions. So they was trying to develop a programming language, okay, that must look simple English, okay, very similar to English. It must be easy to use, even if it means it will be less powerful. Okay, and it must broaden the base of computer users. And finally, must not be biased by current compiler problems. So they were trying to actually develop a programming language that should be easy to use by everyone. Okay, because previously the programming languages, they were actually only possible to write, okay, if you are a computer engineer or computer scientist. So it actually discouraged normal people. Even if someone wanted to learn programming, it was very difficult. So they were trying to, in a meeting in Pentagon, the American defense different Department of Defense, okay, they actually tried to develop a programming language that will be easy to use, especially for business purpose. Okay, and most importantly, it must not be biased by the current compiler problems. So like compilers that we have today, they have resource issues. No, not today, sorry, that time they had resource issues. They were biased to a computer, okay, that is machine to machine, and some of the compilers, they are not optimized at all. Okay, so there were different problems. So they were trying to go over this problem. So uh, what they did, okay, so they are trying to design a programming language, and their design problems were that how should we write the arithmetic expressions, how should we write the subscripts, okay, and how we should get the manufacturers into the one table, because each manufacturer, let's say IBM and let's say Microsoft, okay, these companies, they have their own way to develop a programming language, okay, and they are not actually, they will not come to the same platform that, okay, let's forget what we are doing, let's develop in COBOL. And unless the big companies, the big manufacturers, they start developing a programming language, is very difficult, okay, because else no one will use it. So they had this huge problem. But again, their Department of Defense, DoD, so what they did, okay, they actually develop this programming language, okay, and they also needed this programming language to be widely used in business application. So let's say that in IUBT, we have Department of Tourism, right? We have Department of Agriculture, and so on. So it's very instead of teaching them assembly programming language, if you teach them C programming language, that will be easier for them to remember. Okay, so just think about the comparison. So that's what they were trying to do, that as there are people who are not from a computer science background, okay, so instead of teaching them this complicated assembly and other programming languages that we had in that time, we wanted to teach them this COBOL programming language. Okay, and it will have the same hierarchical data structure, the records that we use. Okay, it will have the long names up to 30 characters, nested selection statement, separate data division, everything. So it will have all the features, but it will be simple. And then they actually develop this programming language. Okay, so this is an example of how all the records are data is divided. So first we have this bit, so smallest unit of data. Then we have this byte, you are already familiar with it. Then you have a field. So in one field we can save one data, just like the database. Okay, then we have a record, that combination of three fields, okay, where we can keep a complete data of a certain person. Then you have a file. In the file you have multiple records, okay, so like all the information of a certain company person. And then we have a database. So this was the hierarchy for the data in COBOL. And to do that, what they did to manage this hierarchy, they actually divided the uh, whole memory management into four divisions. First one is the data division, okay, and then we have the procedure division, and then we have the environment division, and finally we have the identification division. So to go over them one by one, in the identification division, what we stored the identity of the program, the metadata about the program. Then in the environment division, we stored the environment, the source computer, the object computer, the compiler settings, okay, the RAMs and every other informations related to the device. In the data division, we actually store the data, and in the procedure division, we store different functions. So to remember in short, we divided the whole approach into four separate division. In one division, we stored all the identification metadata, so identify the file. Let's think about a movie. Okay, if you are watching a movie, to identify that movie, what we do, we use the name of the movie. Okay, so that's identification data. Then environmental division, we can say that this is a format of MP4 format. This will only run in some VLC player or KM player. Okay, this will need this compiler. So these are the environment division, that if you want to play this movie, you need to have these environments. Then you have the data division, the movie itself. Okay, and in the procedure division, we have like different functions like play the movie, pause the movie, okay, fast forward the movie. So these are in the procedure division. So they divided the program into this way so that everyone can easily manage the program, understand what's happening in each part of the program. And this is actually a good approach. It worked, okay, because overall it apart from this other programming languages concepts that we had, people actually understood this one more easily. And then we had this another language, PLI. So before going to that, let me pause a bit here. So where is it? Just a second. Yes, I got it. So in this one, it's easy to lose track, but let me show you. First, we covered this Fortran. Okay, so this was the first part of our first class. We saw that what is a Fortran programming language and why it became so popular. Okay, we have seen some of the features of Fortran, so you have to study those. And after that, okay, after studying the Fortran, we talked about another language, that is Lisp. Okay, and we talked about Prolog. So you see here, we have this Prolog here. Okay, we have seen the example of the father of how to write a program that will help you to find a logical denomination like father. Okay, then we started this one, Lisp here. If you okay, so now we have seen that Lisp and Prolog, they are two different types of programming language. They are not based on the numerical comparison that we do. One is based on symbol and another is based on logic. Okay, and in the Prolog we call it also a database, intelligent database. Okay, after covering this two, we went to the next programming language. Okay, that is our ALGOL. So why we developed ALGOL? Because scientists were trying to develop a programming language that will be machine independent. Okay, so that, and they can actually exchange algorithms in that programming language, and it's also basic for C program, Python, and many other languages. So then we talked about ALGOL, that it was developed in 1958, and then we saw that the ALGOL was modified. It was first not popular, but after modification it was used for 20 years. So we talked about ALGOL. Okay, and after ALGOL, now we are going to the COBOL. So you see, we're actually little by little we're covering the whole field. Okay, and then we'll gradually go to these programming languages. So in the COBOL, what we have studied, that COBOL is a programming language that was developed for common people's use. Okay, because the languages that we had in that time was actually not that much easy for other users who are not from computer science background, and even for the computer science engineers, it was difficult. Okay, so they divided, they developed COBOL, and under COBOL, there's another version to it that is called PLI that we will study now. So I hope that you don't get lost and understand that how we are approaching. We started with the common programming language, Fortran. Then we talked about a different types of category like Prolog and Lisp. Then we're talking about ALGOL, then COBOL, and now we'll go for PLI. Okay. Here. So again, whenever PLI was developed, okay, they also had the same approach. Okay, they wanted to design a new language that will be used for both side of the users. That means it will be used for one, scientific computing, it will be used for business computing. So when it was developed, okay, then it was called like a programming language that will have everything for everybody. Okay, so doesn't matter which type of user you are. Okay, they try to develop a programming language that will have every features for everybody. So whether it's a scientific computing, whether it's a business computing, you'll have both. So their approach was, okay, in 1964, in the scientific computing, we had IBM 1620 and 7090 computers. Okay, we used Fortran programming language. In business computing, we used COBOL. Okay, so we are using two programming languages in that time. Okay, one was for scientific computing, we used Fortran, and for business computing we used COBOL. Okay, just to keep it simple, we are ignoring the other languages. So they tried to develop this programming language that will, it will be a computer for both scientific computing and business computing, and it will also, they will develop a programming language for both. Okay, so just like the way we use now. So this was actually, that's why it's very important, the concept they started in 1964, and now we can actually use computers in both cases. So the PLI, okay, it was actually first unit level concurrency, that you could execute multiple tasks, okay, at the same time. Then we had the first idea of exception handling. Okay, then we had the switch selectable recursion procedure, that also we can disable as well. We had the first pointer data type that we still use in C programming language. We have first array cross sections, that means we can use 2D arrays. Okay, we can have the third row of a matrix. Okay, and there are some concerns, like as it was a like mixture of too many too scientific, and at the same time it was a mixture of business, too large and too complex.